then I'll show you. For some reason I got disconnected when I was doing this. So again, this is row 1, row 2, problem 1, problem 2, this is J, this is I. For this one, it would be 1 and 1, so 1 plus 1 is 2, minus 1 is 1, so that's pi over 4, and the sign would be 1 over root 2. This one would be 1, 2, 1, 2 is 3, minus 1, 2, 2 pi over 4 is pi over 2, and the sine of pi over 2 is 0. This one is also 2, 1, so 3 minus 1, 2, 2 pi over 4, pi over 2, sine 0. This one is 2, 2, 4 minus 1, 3, 3 pi over 4, you have a calculator. The sine of 3 pi over 4 is 1 over root 2. And then there are some questions regarding complex variables. For example, you have this number. They want you to put it in polar form and graph. Polar form, we need R, which is basically the magnitude of this. And that would be 3 squared, or real squared, imaginary squared, that's root 18. You also need what's called the argument. The argument is theta, and that's tan inverse imaginary over real. So it's tan inverse imaginary is 3 and the real is 3. So it's a tan inverse of 1. And since both of them positive, you have to make sure both of them positive, it means it's in the first quadrant. Because both positive. And that would give you pi over 4. So once you have the argument on R, the polar, you put the R value times cosine of theta, sine of theta times I. So root 18 cosine pi over 4 sine pi over 4 I. And maybe put the angle in brackets. In terms of sketching, now, this is going to be your real, this is your imaginary. So if we say 1, 2, 3, 4, 1, 2, 3, 4, we need the point where real is 3, imaginary is 3. You put a circle, you connect it, and this would be your angle, or the argument. Okay. No, just a sec. Okay. They don't want it. This is if they wanted it to be in real imaginary. But they wanted you, according to the assignment, to graph it in XY. It's pretty much the same concept. If you do it XY. But remember, X would be R cosine theta. and y would be r sine theta. And we figured that r is root 18. So it would be root 18 times the cosine of pi over 4 yeah. It would be 3, and this gives you 3. It will be the same thing though. It will be 3 and 3. Y, it's 1.5, 1.5. I don't really know. I think it's 3, 3. Yeah, it's 3, 3, obviously. Yeah. Whether you do it x or y, it would be 3, 3. Alright, the next one, they only wanted the argument for this one and sketch. We'll do both. We'll do the argument and we'll do the sketch. The argument, we say, is theta, and that's tan inverse imaginary over real. So it's tan inverse of 5 over 4. Now if you do this in the calculator, you will get a bad angle. So just leave it as it is. So this is your argument. This is your theta. And that's what the question is asking for. But if you want to do r magnitude, real squared, imaginary squared, square root of 41. Now, if you want to do it in polar, I told you, the polar form of this will be r cosine theta, sine theta, I. So root 41 cosine, since we don't know, or theta is bad, we say it's tan inverse of 5 over 4. Sine, instead of theta, we say tan inverse 5 over 4 times I. Now, in terms of sketching, this is, again, real, imaginary, or xy, doesn't matter. Your real is 4, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Real is 4, imaginary is 5, and that would be your angle. And this one is right. Yeah, a good question is part 2. What if this a negative? What would happen in this case? Well, argument, again, theta, is the tan inverse of imaginary over real. So it's the tan inverse of negative 5 over 4. Now, magnitude doesn't change. It was still 16 plus 25. So the polar form would be this cosine of the angle, which is tan inverse negative 5 over 4, and sine of tan inverse negative 5 over 4, I. And when you sketch real and imaginary, Your real is 4, so 1, 2, 3, 4. But your imaginary is negative 5. So you go 1, 2, 3, 4, 5. So now this is the point, and this would be your angle. Good? I'll do one quick to show you the concept. Let's say you have something like root 3 and 1i. If you do the magnitude, well, this would be similar to the next question. I'll do, yeah, no, it's not really similar. Okay. I'll do the r first. Real squared, imaginary squared, square root of 4. Your value of r is 2. We do the argument, which is tan inverse imaginary over real. So tan inverse negative 1 over root 3. Now, it depends on your calculator. If you do tan inverse of negative 1 over root 3, in degrees, it will be negative 30 degrees. And in radian, it will be negative 5 over 6. So, if you want to do the polar form, it's the magnitude cosine of angle. If you put negative 30, put the degree with it. If you put negative 5 over 6, just put negative 5 over 6. And if you want to sketch we have real root 3. Root 3 is very close to 2, a little bit less, so here. And negative 1, this is negative 1, so this is the angle, or this is the point, and this is the angle. Good? Okay. We go to the next one. They give it to you in the reverse order, so they give it to you in polar form. So in polar form, it's 4 cosine 1/3 pi, or pi over 3, plus sine of 1/3 pi, and graph it. Okay. Now, from this, I know that the argument, theta, is always tan inverse of real over imaginary. Over real. I don't know what my imaginary is, I don't know what my real is. So I know that tan inverse, let's say this is the form, it would be y over x. So the tan inverse of y over x is 5 over 3. So this is one equation, that the tan inverse of y over x is 5 over 3. To get rid of the tan inverse, I'm going to tan both sides of the equation. tan the tan inverse, and tan the phi over 3. Tan inverse cancels out. Tan phi over 3 is half. That means if you do the cross multiplication, 2y equals x. Or if you want to make life easy, you just remember if you have it in polar and you need to switch, y over x would always be tan whatever the argument is. So you could just say y over x equals this right away. Instead of, I'm just showing you how you get it. Okay. We also have this, that the value of the magnitude is r. And if you remember, r was the real squared, imaginary squared, and according to this, it's 4. You square both sides, so you go x squared plus y squared equals 16. Now instead of x, I put 2y. I have 2y squared plus y squared equals 16. This is 4y squared plus y squared equals 16. Where do I write? I'll see if I can. So we have 5y squared equals 16. Y squared is 16 over 5. So I square root this number, and I'm going to take the positive, because everything is positive. We're in the first quadrant. So y would be root of this. That would be 4, 5. And from here, oh, I did something wrong, actually, in some of the calculations. I'm going to do it again, sorry. And I'll simplify it this time. Okay, here we have theta. I told you y over x would be tan of theta. So it would be tan of phi over 3. In fact, tan phi over 3 is not half. Cosine phi over 3 is half. Tan phi over 3, if you use the calculator, would be root 3. So now y over x equals root 3, meaning y equals root 3x. Now we look at the argument. R is real squared, imaginary squared. So you're given R at 4. You square both sides, so you have 16 x squared plus y squared. Instead of y, you use this. I gives you 16 equals x squared plus 3x squared. So 16 equals 4x squared. You divide by 4. 4 equals x squared. And again, you're in the first quadrant, so everything is positive. X would be 2. If x is 2, then y is 2 root 3. So your G number, real is 2, imaginary is 2 root 3. And if you want to graph it, 1, 2, 3, 1, 2, 3, 4, 5. 2 is, this is the 2. 2 root 3 is 3.5. So it'll be like somewhere here. This is the point. It's better if you just stop at this point and make it a circle, and this is the tape. So this is it for assignment 9. Hopefully you have no problem with it. We'll see you when we do the next one.